below you can see something that's obviously called a solubility chart. Now, a solubility chart is an easy way for us to combine all the information we know about all kinds of salts, which, by the way, is just a generic way of saying something that's positive bonded to something that's negative. So all salts that exist, it's our way to generically figure out quickly if they are soluble in water or not. There's a lot of chemistry that goes on in water, especially in General Chemistry 1, and that's why we worry about it. So you'll see there are two parts of the solubility chart. There's the soluble part. So up here, this is soluble. And then we have our exceptions over here. So then we have a second part to the chart, and you'll see these are not, and then we have our exceptions. So it's kind of like generally most of these are, but there's a few issues, and then generally most of these aren't, but there's a few issues that are. That's why we have two kind of little categories going on. There's a few ways to go about using this chart that make it easier to use, and these two tips at the top are very important. Sometimes when you get to looking at salts like LiCl, you're like, oh, there's a positive part, there's a negative part. Which part do I look for when I'm looking on the chart? Well, there's only these positive ions on the chart. So you can see like it's this row and this row. If you keep looking, the only other one is this H+. Everything else is a negative. So what you should do is just do a quick check on that first one. The first one's going to be the positive one. So you're going to do a quick check on this one to see if it's any of these. If it's one of those, you don't even have to look at the chart. But if you want to look at the chart, it's that first row. So if it's one of those, don't look any further. Don't do anything else. It automatically means that it's soluble. It means that we write an AQ after it. That stands for aqueous. And that when we put it in water, we should realize that it breaks apart into Li+ and Cl-. And you still keep the AQ with both of them. So the other kind of thing you want to watch for is this other positive ion, this H+. So H+'s are actually acids, but I went ahead and combined it into this chart because I think it's helpful to kind of have everything all together. So they do dissolve in water, but most of them do not break into ions. So folks will get used to seeing this AQ, and when they see AQ, they automatically split it apart. And that works perfectly for salts, but it doesn't work when you have H's in there. So if you have like HClO3, this is something right here, H, and notice it's not one of these exceptions. So it's something that will not break apart, but we still write an AQ with it. So it's kind of weird about the acids. Besides that, the chart's pretty easy to use. It might look overwhelming at first, but try not to overthink the chart. Again, just remember if it's check your positive ion for any of those four, and you can tell these ones are all in that first column, that alkali metal column. And then this one is the other one, that's ammonium. And then this one right here, you'll get used to this one after a little bit. All right, so let's look and see if we can use this chart for these ions right here, or these salts right here. So let's start with the LiOH. So remember, always check, do you have an alkali metal first? Li. Well, yeah, you do. That Li right there has something on the front that's an alkali metal, so it means it's automatically soluble. We're not even looking at the chart with this one. And it means when it breaks apart, it will break apart into Li+ and OH-, and they'll both have the AQs beside them. Again, let's look again at the first ion. And all these, we're going to check the first ion first. So again, this K2, yeah, that is one of those first columns. So again, this is going to break up into two K+. That means a K and a K. And a CO3, 2-. All right, that is not one of those special ones. That's not one of the special ones. That's not. Now the RB is, that's in that very first column on the chart. Periodic chart I'm talking about. The periodic table, that's the very first column like the other two. And so this one will automatically break apart. And then this one, again, it's not one of the first exceptions. So we've already checked all these for this section here. So now we can actually use our chart. We might check it real quick to see if we have any H's, but there's no H's in the list. All those are metals. So now we can look at the negative part for stuff we haven't figured out, which would be this one, this one, this one, and this one. So we're looking at the negative. So here's an NO3 group. So we're going to go up and find our NO3. And I always just say to read from the top down. As soon as you find something that applies, just stop. Don't look at the rest of the chart. It's easier that way. And as you go further down the chart, it gets more complicated. So start at the top where it's like easy. So you'll notice right here, I have an NO3 group right there. And over here, do not dissociate. So NO3, I don't have any exceptions. There's nothing that is an exception. So it means that anything with NO3 in it also will break apart. So that'll break into Ag plus, NO3 minus, and they both will have AQs with them. Now, I did remember, I actually happen to have another NO3 over here too. So I'm going to look again, just remind myself there's no exception. So that has to break apart also, and it will get an AQ for aqueous. And that's 3 NO3 minuses. And like I was saying before, the 3 in front, it means that there's 3 total right there. All right, so now we just have 2 more left. So we're going to look for an OH group. So here's our OH group, and you'll notice, oh, normally this would be insoluble and you'd write an S, but this barium is in the soluble section. So this one also breaks apart. It has an OH minus, and there's 2 of them. And then lastly, we're going to check this one, the CO3. Here's our CO3. Okay, so there aren't a ton of exceptions, but we do need to note that if it's with H, it's going to break apart into a few funny things. So over here, FeCO3, that's not an H there, so that one will stay stuck together. So of all of the examples that are shown here, only one of them is going to basically not dissolve in water and is going to stay a solid.